All right, here's a few more examples of using substitution. So for this one, we have our two different equations. This one already is set up so that y equals something. So what I'm going to go ahead and do is take what y equals, and I'm actually going to substitute it in for y. So I'm going to rewrite this first one right here. I'm going to move this maybe a little bit and rewrite this problem, and instead of having y, we're going to plug in what does y equal. So I'm going to rewrite it as 4x plus 2, and no longer am I going to write y, I'm going to write this information in here. So I'm going to put my parentheses, negative 2x plus 4 equals 8. Next thing I'm going to do is distribute. So I'm going to distribute the 2 to the first term and then to the second term. So I'm going to rewrite my problem as 4x, and then 2 times negative 2 would give me a negative 4x. 2 times a positive 4 gives me an 8 equals 8. And then you're going to see 4x minus 4x, well, those cancel each other out, and I'm left with 8 equals 8. And for this one, your solution would be infinitely many. And some people will even write infinitely many solutions. This next one, again, neither of the problems are set up to be on its own. Like it's not x by itself or y by itself. The easiest looking one, and it's okay, some of you might choose this problem and solve for y. Some of you might choose this one and solve for x. Some of you might choose this and solve for x, and some of you might choose this one but solve for y. They should all work as long as you're doing it correctly. I'm going to go ahead and solve this one first for x. It just looks the easiest, and I know I'm just going to subtract the 4y from both sides. So I'm going to end up with x equals minus 4y, and then that should be a plus 3. Now that I have this information of what x equals, I'm going to plug it in there. So I'm going to rewrite that problem as 2 times negative 4y plus 3 minus 3y equals 17. I need to distribute the 2 to both terms. I get a negative 8y plus 6 minus 3y equals 17. I can see that I can combine this term and this term. Those are like terms, so a negative 8y minus 3 gives me a negative 11y plus 6 equals 17. Minus 6 cancel. Negative 11y equals 11. Divide by negative 11, divide by negative 11. I'm running out of room. And I end up with y equals negative 1. Now reminder, you've only found one ordered pair, because remember, our goal is to find what x and y would be. And we now know y is a negative 1. Once you have that information, you can go ahead and plug it back into, we could do the first one. So to solve now the first one, I'm going to plug in what is actually y. So jumping, whoops, sorry, you can't see that. I'm going to go ahead and take what y equals and plug it all the way in here. So I just found out that y equals a negative 1. So I'm going to go back down here, rewrite that original problem as x plus, 4 times y, and y we just solved right here, and is a negative 1 equals 3. Multiply these two together, so now I'm left with x minus, technically, or plus a negative, minus 4 equals 3, plus 4 cancel, and x equals 7. I'm going to take that and I'll plug it in here. And so the solution, by using substitution for these two equations, would end up being 7, negative 1.